Hi guys, my name's Ian Cooper, and hopefully you've come to hear me talk about service consumer patterns. So just a brief idea, what are service consumer patterns? So if you've built your microservices architecture, one of the things you're going to have to come to terms with is how your clients or how external partners are actually going to communicate with those microservices. And this talk is about the challenges that you face moving from, say, a world you're used to in monoliths to the world of microservices when you want to actually go ahead and do that. So today we're going to start talking about a little bit of a very short dip in just to refresh our memory of how we did this in the world of monoliths. And we'll look at two separate ideas, how we issued commands to our system in a monolith and how we queried our system in a monolith. Nothing earth-shaking here, we all understand that, just for context. And then we'll look at why the changes we make with microservices. We'll have a tiny bit about what a microservice is, um, why that we then get a challenge with microservices in using these same strategies. And then we'll tackle the problems in two parts. We'll look at queries first of all, how we compose queries to our monoliths, and we'll look at commands, how we actually issue requests to our microservices to do things. There's a lot to get through, so we'll have to move quite fast, and we'll have a little tiny summary at the end. Most of the slides are unimportant, just as I'm old. The point I really try and draw attention to is the one at the bottom. Everybody really can get into speaking, and actually, nowadays with the pandemic, there's probably lots of opportunities to do little short talks at user groups around the world. So please do. It helps you get your head around topics if you have to teach them. And once you get over that initial hurdle of fear, it's really a great experience. I work on an open source project called Brighter. We deal with messaging in the .NET and Python worlds and kind of CQRS approaches. We're always looking for new contributors. You can find us essentially by just searching for Brighter command, and you'll find us really easily, or just hit me up afterwards in the Slack channel. This talk is one of kind of a pair. So last year at NDC, I talked quite a bit about event-driven collaboration. There's a tiny bit of crossover in concepts, but I won't dig into too much detail on some of those ideas in this presentation. And if you're interested in them, I'll just basically signpost that you can go and see my last NDC talk for more of a deep dive on some of those ideas. All right, so the first thing we want to start talking about is what did the old world look like? Or for some of you, it still is the current world, right? So what is a monolith from my perspective? From my perspective, a monolith is really something where when we talk about deployment, we talk about deploying everything within the system boundary. Usually, the constraint that makes that thing the monolith has to do is the fact that we have one shared database. And because a change to the schema of that database can ripple out to affect any number of actual components which talk to the database, then we end up with basically this idea of a monolith. Now, it may be that we are able to say, well, actually, I don't have to release every single thing in a monolith. I only have to release the things that are impacted by the schema change. But what happens is, in my experience, we end up with release meetings. We all sit around discussing that we found everyone's impacted by this change. We deploy to staging, something breaks in staging, and then we have to go back and figure out who that belonged to. Or worse, it breaks in production. And what that means is that the cadence of our release slows. And I quite often see this happening in most places I've worked in a kind of 2-week release cycle to get things out the door, which means that effectively, by comparison to your competitors, you could be releasing multiple times a day. This can be a problem. It's also much harder for multiple teams because all these teams continually have to coordinate their releases. One of the things we're trying to show here is that you might actually have components running in different containers. You might have 4 or 5 APIs that are all hosted on separate parts of your, say, IIS or in separate Kestrel or separate, basically, Django websites, whatever your flavor is. But because they're all sharing a database, they all have this constraint that they have to be released under a single boundary. But let's imagine a world that our monolith essentially has some components. It's probably all released as kind of one big website. and we built something that dealt with hotel software. Now, I apologize to everybody who may actually have dealt with hotel software at some point in their life, because I know nothing about hotel software. I just use it as an example because I know nothing about hotel software. I can move away from the details, and most of us have some experience of checking into a hotel, so we kind of understand what I'm talking about. So in the old world, I might have a kind of traditional layered architecture. I've got my API at the top. I've got my domain model, which is nicely modularized. Model is not a pejorative term, just a description of certain characteristics it has. With my big database at the bottom, and potentially I've got some ORM feeding data. And let's imagine the situation where I wanted to make a hotel booking as an existing customer that held an account with your business. Oops. So, getting the work done for a command. I decide basically to post my new booking. It comes in via the API from whatever client I'm using, be it a Spire application or something like that. And then effectively what would tend to happen is I would create a new booking using the direct bookings module. I've got some types in there I can create stuff with. And then probably I would save that early form of the new booking saying I had a tentative new booking to the database via my ORM. Then I'd know in terms of my business logic that I now needed your account information, because that's where I held the credit card details, and I was going to submit those to my payment system. So I'd then read from the database and get your account details back by the ORM. And having got your account details and getting the credit card information, I thought I could then submit that to the credit card payment system. Credit card payment system would probably call some kind of external payment provider like PayPal, etc. And once we got a message back saying that your credit card had sufficient funds and you could book the hotel room, I probably then talk to the housekeeping system and say, I'd like to reserve a room for this customer on this date. Housekeeping would then write to the database and say, let's store that particular room reservation. And then we might talk to a channel manager. So a channel manager talks to booking.com and Expedia and says, we have a number of rooms available in this date with this range of prices. We may update via channel manager, hey, this rooms are really in demand right now, so let's basically up the prices. And again, that may talk to some external basically site to get the actual basically channels. And of course, you probably get the list of channels from the database. And as you can see, it's a fairly straightforward series of interactions, because we can just reach into the database at any time and get the data that we need to fulfill the next step in the workflow. I mean, update the booking at the end. On a query, well, let's assume, I want to basically assume that we built a decent monolith. Let's assume we've decided to go for a kind of CQRS model. We're not going to go through our entity model in the domain in order to basically get some data back. Like, for example, you walk in, you head up to the front desk, you want to check in, and I want to get up your details of your booking, the room reservation, and maybe some information from your account so I can determine effectively some personal preferences that you want set up for your room, or effectively make sure I call you by the right name. And in a simple CQRS model, I've just got some kind of query layer effectively, which I can then use to go and pull all the data I need out of the database, join it together, and present some nicely prepared view back on screen for the user sitting basically at the check-in desk at the hotel. All right. So let's talk about how this picture changes once we get into the world of microservices. So first, a short version of what my definition of microservice would be. So I come from an SOA background, and I tend to think microservices is kind of SOA 3, SOA 2 was events, SOA 1 was web services. And it has some additional constraints coming from domain-driven design, from DevOps, even from things like REST and Gorilla SOA, which was created by Jim Weber. And all those have essentially created a series of additional constraints to help do microservices successfully. But I can think of a microservice as something that has the original 4 tenets. It has an explicit boundary. In other words, you can't reach in and talk to my data. You have to go via an API. The API could be HTTP, gRPC, it could be messaging, it could be AMQP, Kafka, etc. Right? And it's autonomous. That means I release everything inside this boundary together. Now, I also release everything inside the boundary together on a monolith, but here my system consists of a number of smaller pieces called microservices that are independently deployable, which means that actually I'm deploying a smaller part. And generally, a team is quite often oriented to owning a microservice. So the team now controls its own release cadence, and we get into great ideas like products, not projects. And we'll skip schema, not type, and compatibility, not policy, because it's not important to this conversation. But we own and we're the single writer of that data. Nobody else can write that data. They have to come through our API to do that. And in terms of what partition strategy we choose, how many of these things do we get? I still am a believer in the kind of SOA approach, which says we're aligned to a business process, right? And so there are various ways of doing that. I have a separate talk, which you can see I gave at NDC London about basically capability mapping. But generally want to slice our system up into business processes and align these microservices with processes. So imagine this is what a hotel looked like in terms of slicing up into business processes. It may not do, I don't know, don't build your fortune on this. So imagine we basically said, very similar to our modules, in fact, in our monolith, we had a direct bookings microservice, credit card payments microservice, accounts, housekeeping, and channel manager microservices. How do we now run those same scenarios we were looking at earlier in our new exciting microservices world? When we think about commands, by commands, what I mean is we issue some instruction or request to the backend microservice to update something, to change something, to carry out some work, for example, like making a hotel booking. One of the questions is going to become, how does that work actually happen? So this is a typical kind of layout I might have for a microservice. You can see we've got a bus down the bottom. So our microservices tend to be integrated by an asynchronous communication protocol using some kind of messaging transport. So Kafka, RabbitMQ, SQS and SNS, Azure Service Bus, whatever your flavor of choice is. And my individual services essentially listen for events on the bus. And that's how we've chosen to do most of our interop, because that gives us nice benefits like we're decoupled in terms of time and behavior from other parts of the system. And above them, I've got some kind of gateway layer. We'll come into more detail on what that is later, but that's some kind of layer which says I need to access potentially one or more microservices at a time. Okay. And I've got potentially partners and clients who want to talk to my microservices. So imagine that same scenario again, where I want to basically create a new booking for a hotel room. Well, actually now what's going to happen? I call the API to take a direct booking, but how am I actually going to start the work of doing the other steps in my flow? Getting my credit card information out of the account, taking the payment, reserving the room with housekeeping, updating the channel manager. Because direct bookings has its data about booking, but it doesn't have the data that lives in the other microservices. And the rules say I can't reach into their database and get hold of their data. So I need some other mechanism to basically to ask them what to do, or rather give them instructions what to do. So the obvious answer I might reach for is, well, they've all got an API, just like everything else. So I can just use their API from the client. So I could call my accounts microservice and say, well, give me the credit card details. And then I could take the credit card details and I could say, hey, credit card payment service, please take a payment on this credit card. It would then talk to basically the reserving of a room. It'd say, please reserve the room for me. And then essentially after that, I'd update the channel manager. Right? And that seems quite promising, but there are a couple of little details that we need to think about at this point. The first is we've essentially built an old school client server model. All of the business logic now lives in my client, not actually in my microservices. And that can be difficult because it means whenever I want to update my workflow, I have to update the client. My client has become smart and my actual services have become quite dumb. And this leads us to basically a problem called an entity service. We don't want our microservices to just be focused on entities. Okay? So if you create a microservice which is literally doing CRUD operations on a single entity or even an aggregate that effectively you keep updating, your problem is the business logic, which ought to live with the microservices, has now drifted out to the client. So if a team wants to effectively change how the booking process works in terms of their aspect of it, they may struggle. All they've got control over is CRUD. All the pressure is going to be on the front end team, which continually has to update the workflow whenever any changes happen in the downstream systems. So that top model, basically the entity services, is regarded as quite an anti-pan. And Michael Nygaard, the guy who wrote Release It, has a really good blog post basically about the entity service problem. And when I share the slide deck at the end, it's linked to the bottom, you can go and read that. A much better model is to remember that our microservices are focused on processes that form part of our customer journey or part of our operational support for customer journeys. When we think about that, we can say, really what we want to do is have a new booking process which handles all the aspects of new booking and then effectively passes the torch onto reservations and passes the torch onto payments and passes the torch onto channel manager, so that effectively we have a flow of information through our system dealing with the booking. And then we can keep the business rules that apply to that particular process with the data of that process all inside our microservice. The other problem is if we think about it, we're going to make a series of calls here. So let's say our post takes a couple of 100 milliseconds, our get 100. Our credit card payment takes a lot longer because essentially we have to make a call to an external payment provider and they usually take forever to basically service our requests. Housekeeping, well, we're just doing a quick post, maybe that's okay. And channel manager, again, we're in this world where essentially we're probably making an external call to Expedia, Booking.com, we may be making a series of calls, and effectively the latency is going to build up. And so for our individual user sitting in front of their computer or on their phone looking at the client, there's going to be quite a wait. And if it's in a browser, we're going to be the people who put the message up saying, please don't navigate away from this page, right? Now we might say, well, some of these operations can be done asynchronously, but we've still got an end-to-end process to complete here, which is being run by the client. So that again doesn't seem like the best solution for us. All right, let's switch to a track and look at the problems we're going to get with queries in our microservice world. So just park your thoughts about commands. We'll come back and we'll explain how we solve some of those problems in a bit. But now let's basically have a look at queries. What are the problems we get with queries? Well, queries might seem a lot easier. So let's say essentially you turn up at the hotel and you go to the front desk and you say, my name is Mr. Cooper and I should be booked into this lovely hotel in Portugal because I'm staying here for NDC Porto, and a lovely crew at NDC will have booked me into my Portuguese hotel and they look for my booking. Then the system is really going to have to go maybe probably and talk to things like direct bookings, accounts and housekeeping to get that data. And this seems much more straightforward. I can just use the API to get hold of all the data that I need in order to basically service your request. But again, bear in mind that effectively I've now got a considerable amount of latency in calling that request. Is there a better way of doing that? Is calling all three of those services and basically me then as the client taking all of that data and munging it together myself effectively before I can display it? Is that the best approach, or are there other alternatives which would be more efficient? And again, we'll talk about those. And overall, I think of this problem in microservice, I sometimes abstract it as calling it the join problem, right? Before, we had a single database, and it was really easy for us when we were querying to join data between two tables in order to basically produce something like that said Ian's booking information for the front desk. Once we get into a lot of microservices, because every microservices is now managing a portion of the data that we hold, joining now becomes harder because we're actually doing that basically via HTTP across multiple microservices. All right, so let's have a look at some kind of solutions that we think we can use to solve some of these problems. So we'll start with reads and then we'll move into commands. So I drink some water. Okay, right. So here's that kind of model again. When we talk about a gateway layer, I'm going to talk about a number of things as being in the gateway layer. So when we talk about gateways, particularly API gateways, some of us tend to think to ourselves, oh, that's an off-the-shelf product that I can deploy in AWS that essentially sits in front of my service, etc., and does some load balancing and routing. And I want to avoid that kind of concept. Gateway for me here is basically acting as a layer that sits over our microservices and manages essentially some of the interaction we have with that. So we're ignore process managers for the time being, just focus on kind of API gateways and BFFs and that level. All right. So what happens when I check in? We said when I check in, I'm going to want to go and get some data, right? And I'm going to probably want to go and at least check on the account information, get some of my personal details back, perhaps even the credit card I've got on file so they can check with that. And I'm going to want to check with the housekeeping system about my room reservation. And so naively, we might just say, well, the simple answer here is that I essentially just call basically accounts and housekeeping, right? Effectively, and I say, maybe I start with basically accounts, and I say, go and find Mr. Cooper's account information, and then see what bookings he's got. Here's one for the day. Or I could do it the other way around and say, let's go and look for reservations on this date, and then I'll pull in the account details for the matching account holder. Well, we might think, what I'm going to do is just compose that information basically in two calls. I could, but maybe another alternative. And that is that rather than making that other call, well, I could potentially just return it in one API call. And this comes up a lot, particularly when people start to compare REST with GraphQL. People say, oh, the problem with REST is I always have to make multiple calls because my REST-based service only owns data for kind of one microservice. And that doesn't necessarily have to actually be true. So let me take you through the journey of an idea called reference data. So reference data is an idea created by Pat Helen. Pat Helen was an architect at Microsoft and at Amazon. And Pat wrote a number of papers which are very useful for understanding how to build successful service-oriented architectures. But what we need to understand for the point of view of reference data is that we said earlier that my service essentially owns its data, and it's the single writer of that data, and it has an explicit boundary. But the reality is, when I call that service to say, get some booking information, data leaves my service and travels outside of it. There is now an on-the-wire piece of data which refers to something inside the microservice. And it has a number of important characteristics, right? The first is that that data essentially is stale. As soon as it leaves basically that system, it becomes stale because someone could come in and update the booking information, and my consumer working on effectively the get that they've got previously has slightly out of date data. So quite often what we tend to do is have some kind of version or timestamp on the data so we can tell how current it is. This should actually say last modified rather than if modified since, really. But we're saying basically, here's a date and timestamp that's produced that, so you can check on later and see if you've got the most current one. And cache control would be an indicator for how long we thought it was safe to keep using this version before it was likely someone else had updated it or changed it. The data left. It's also effectively immutable. There's no point in you changing the information you get back as a result of the GET request. It doesn't actually update the booking information. The only way to change the booking information is by an API call to the direct booking service itself. And that data doesn't have to be HTTP messages. It could actually be an event that I've raised. And that event itself may have some information on it. And that may include things that, again, like the version basically of the booking information just received. All of that data we tend to call the outside data, and we tend to call the data inside the service the inside data. Now, the really interesting thing about outside data is it's highly cacheable, both i.e. from it comes from basically a GET, which you're used to caching, but even information I pick up via messaging from another system is also very highly cacheable. And we talk about this more in the event-driven collaboration talk, but the idea to think about here is this. If I was to call the accounts system regularly to get your account details, I might think to myself, I could cache that API call and store your account information so that effectively next time I needed it, you'd be able to get hold of it. The trouble is, of course, generally speaking, I might have to visit a given hotel once, twice a year. And so it's very unlikely I'm going to get cache hits basically when you turn up at the front desk. But if I could pre-build the cache such that effectively when you turned up, your data was already in the cache, well, then that might be a way of avoiding me having to make the call across to the account service. And so this leads to this idea called event carried state transfer. I think Sam Newman actually calls it a data pump, and I've also seen it called reference data by Jim Weber and in Robinson, their book Rest in Practice. And the idea is that what I could do is listen to events from the account system. And I assume that the account system produces an event when anything changes in the world of accounts. So, for example, I change my address, I change my credit card, to update it because the old one basically was out of date. I change my name, for example. Whenever any of those happen, what happens is housekeeping is listening to those events, and it's building in a cache of information it needs about accounts. So generally speaking, it's probably storing my postcode, my credit card, etc. details. And it's able to keep building up that cache in response to events. And that means when effectively housekeeping basically is asked, well, can you get me the account information that's attached to it? Can you get this reservation details? It can actually attach account information to that reservation. So rather than simply having to go make the second call, it can say generally when we get a reservation, we also tend to give you the last 4 digits of the credit card, the customer's postcode and date of birth, so you can check it's really them by asking them a couple of simple questions when they get to the front desk. And I can return that in the original response. So I'm now only making one call. Very common use of this is if I store product IDs and I want to attach the product description. So I work at Just Eat, some of you may know. So if I've got a menu ID attached to an order and I want to attach basically the description of the menu item, if I had a local cache basically of that menu data, I could then attach the relevant description rather than calling a separate service to obtain that data. And then I can read that customer info. And that means I turn that into one call rather than essentially two. All right, let's have a slightly more complicated scenario. Let's say what I want to do is measure the effectiveness of my given channels. So what I want to do, I'm a manager sitting there and I'm trying to find out how much I sell through Booking, how much through Expedia, how much through Google, and whatever the services are that the aggregators. So probably what I want to do is look in my system and say, hey, find me each channel, group for each channel, the data that belongs to the individual bookings, and give me a summary of how many bookings I had per quarter for each of those channels. And again, naively, my approach might be, well, I'm going to call the channel manager, get a list of channels back, and maybe I'm assuming my booking information has an ID of a channel that basically made a booking, and then I will pull back the list of bookings, and then somewhere in my code, I will essentially do all the grouping of that data between the channel manager and bookings. Don't forget, whereas previously I might have done this by querying my database and relying on SQL to actually group up all the summary information for me. At this point, if I'm doing it in the partner, it's going to be client code running in the partner that effectively has to basically do all the grouping and take all the booking information and spit out the report. And that seems kind of ineffective, right? Because essentially I've moved all the business logic for creating that report out to some consumer of these two APIs. So what can I do to solve that problem? Well, the answer looks very similar. So if I take this notion of event carrier state transfer, I can say, well, hang on a minute, my booking service and my channel manager service are constantly creating events. So if I add a new channel manager or remove a channel manager, etc., then effectively I'm going to have an event. So I could listen to those and come up with a list of channel managers. And then when I see a booking, I could say, well, when that booking comes in, I'm going to basically aggregate under that channel manager the number of bookings that have been made, total value of the bookings, etc. And I can do that per quarter. So I'm listening to those events, and over time, I'm building essentially a database that gives me the reporting information I need. And that channel vector database can be written such that effectively my query from my API is a very simple call that probably just reads a row out of the database. So it's very fast and efficient. Some folks call this a composite view model, where essentially we are building a model that can answer given query questions for a consumer. Pat Hill in his discussion of reference data refers to this as historic artifacts. When you think about something like a data lake in your enterprise, quite often data lakes are just really large scale versions of this, right? So your data lake is quite often listening to all the events that are flying out of your microservices and building a complex model in order to do analytics against. But even at a really simple level, it can help you essentially build responses to particular front-end queries. Okay, so it's a really easy one to do, and it's very effective at building fast report type information. And again, when people talk about GraphQL versus REST, one of the things they miss is that if you understand what report you're going to build, it's very easy to do that with REST, provided you can kind of pre-build the data that you need to answer the question with. Oh, and we have some fancy animation. Behold my animation. Hear me. Okay. All right. Quick glass of water. All right. let's imagine a final kind of scenario, and I'm going to basically push this scenario a little bit just so we get a different example. Let's imagine I want to basically search for going to stay in Portugal, and the particular hotel brand I pick has 3 or 4 different actual hotels in Porto. And imagine there's like Radisson has Radisson Blue and different, it's got a budget entry, it's got a luxury entry, maybe it's got some boutique brands, etc. And I'm going to their site and I want to know what's the range of things that you offer me. Okay, so I'm typing in some information saying where I want to go and visit, and I want you to give me answers across all your properties. And let's imagine for the minute that the nature of this information is fairly real time, because there's a big conference happening in Porto, bookings are happening rapidly, and it may well be that I want to get up to the minute information. The thing about the last example we saw, the composite view model, is that tends to be often used where the flow of change is sufficient. You're probably talking about a rollout that happened. It doesn't matter if you see data that's basically, a little bit old by eventually a few minutes or so, because messages are still in the wire, because generally it's a position of data that is indicative rather than has to be exactly right. So imagine here that the data is changing very fast. Now, actually, you can use the composite view model to solve a lot of these problems, because you're probably processing your data fast enough to keep updating your position for a group search. But let's imagine we can't. Let's imagine the product manager has essentially put his foot down and said, no, 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 I must have near real-time booking information. So in this particular case, the problem I've got is that I need to go to direct booking and I need to go to property services, but I can't pre-build the view of what I've got. And this tends to be where you really do need to do actual composition in a gateway layer to say, I'm going to call both these services, I'm going to combine the data together. So what we do is have some kind of gateway API that essentially says, I provide the API for hotel group search. You call me, I've got my own REST API I've written, and I will internally then make the calls to direct booking and property services, and I will then manage the data together to show the customer by whatever criteria they put in, basically what hotels are available right now in Porto, given, they said they don't want budget, they only want, luxury and boutique hotels, explain it to them now. So why is this kind of gateway layer? Well, if you think about people like Netflix, when Netflix originally were the kind of pioneers of this kind of model, this API for Netflix was built originally in Java, and their Java API effectively sat over their actual fine-grained SOA, their microservices, and made the calls directly to them. And so this layer acts as the one that gives the API that basically joins data across multiple microservices. Now, as I said before, I wouldn't go to this if you can solve the problem. It's just a simple problem of what we need to have is some additional operand data, which just says what is the customer's address, what is the customer's credit card number. I do that via event carrier state transfer. And if I needed a composite view model, I could pre-figure out the query. I might well do that. But this model says I'm going to do it in real time. I'm going to call multiple services and compose the answer. And you can think of this basically layer as a proxy. It's a proxy that sits between you and the microservice API and manages those calls. And that has some kind of interesting characteristics. It's not just usable as a composite API or a BFF. So a BFF basically really, which is Sam's term, BFF is really one of these, but it's built for a specific client. So a BFF says, actually, I'm going to build one of these, but it's going to return data in just the shape our Android client needs it, or just the shape that this third-party organization wants that data, as opposed to an API gateway generic, which is basically just a generic gateway that I can use for any number of clients. The reason you might do the more tailored version is to basically make sure that you're not returning unnecessary data to the consumer, so you can minimize the cost over the wire. And given this piece of data, given this proxy layer in the gateway, I could say, well, to be honest with you, I could put some other things in here. So this is what Netflix did with Hystrix, right? It said, you know what, given that I'm now temporarily coupled to any of these microservices, It's possible that I get some transient network error talking to them via HTTP. It's possible that for some reason the instance the load balancer sends me to initially is bad, and I failed to tell check I need to go to another one. And I can do things like do a retry. I can circuit break basically to stop going to things that are bad for a temporary period. And maybe when I do that, I can serve cached results because maybe the hotel bookings haven't changed fast enough that I don't have to worry about that. I can rate limit here. I can say effectively I'm getting too many requests because everyone wants to travel to Porto. So I'm going to tell my clients to slow down with the requests I'm receiving. Um, and I can load balance at this layer across a range of available instances. So this is where we tend to get into the notion of API gateways as a product that are doing something, because I can have all these useful additional properties that I start managing at the layer of the gateway itself, which are kind of slightly orthogonal to its role in being the place that's providing a new API, which makes calls to our microservices, but actually become part of the requirement for you when you start to say, I need to call 4 or 5 microservices to return the result. And therefore, I have a more complex problem of saying, well, I'm now dependent on 3 things. So the availability of my service is dependent on the multiplication of the SLAs of all of those 3 items. And so I need to manage that result more with things like retries, circuit breakers, etc. All right. That's talking about reads. So roughly just kind of remember the event carrier state transfer can help you solve a lot of problems by effectively either letting you bring in the additional data you need to make your REST request slightly more informative, or it lets you build ahead of time some kind of composite view model to answer the question. If not, you may need to go to kind of composition at the gateway layer. What about conversations? What about rights? Okay, so imagine that I want to now handle a command with this architecture. So I want to basically create a new booking, and we looked at that. That was the kind of first example we looked at in our Monolith. So I'm saying, hey, a new booking comes in, and I'm going to write that basically to my direct bookings, and bookings is going to then raise a message because we've got nice asynchronous communication between our microservices saying a new booking has been made. And what we want to happen is that the customer gets charged for that information, charged for that booking, and then we basically reserve the room in housekeeping and a channel manager. But what happens now, effectively, if I try and take the payment? The problem is going to be that I end up in a world where um, the credit card payments doesn't have the account details for the customer to get the credit card information. So how do I get hold of that credit card information? Because the booking's just come in, right, on account, and I don't seem to have it. How would I get hold of it? And naively, what happens in a lot of people when they're discussing kind of how microservices work is they say, oh, once you've received the notification it's a new booking, you would make a call to accounts via accounts API to get the credit card information, etc. that you need. The problem with this is that earlier on we said we wanted a nice asynchronous communication between our microservices over the bus because we wanted some benefits of decoupling both temporarily, in other words, the other source doesn't have to be up, and in terms of behavior, we don't have knowledge of all the other calls you have to make. But we just recoupled as soon as we try and reach into accounts to get hold of that data. So how do we solve that problem? So there are 2 main solutions, and we can think of these basically as both being push models. In the left-hand side, we can see a model where we're saying, well, the obvious solution would be to make sure that the time that we message reaches credit card payments, we have all of the data we need to make a payment in that message. All right. And so the question is, well, how do I get hold of that data? How do I get hold of the credit card data from the customer's account to pass the credit card payments, basically, when it comes in? The second option is I have some kind of cache of the account data. So as the credit card payment simply says, I can answer that question myself. I already have the credit card details for the customer. Okay. So look at how I solve both those problems. So choreography is the name we tend to give to the idea of having a pipeline through which a message flows. When we receive basically a request to do something, we flow that particular request through a pipeline of services that all take a hand in delivering. Why is it called choreography? Well, I tend to think of it this way. When people perform a dance, essentially, a choreographer is there beforehand and helps them basically figure out what the dance will then look like. But in the actual performance, the choreographer is not really present directing things. The dancers essentially are on their own. And in the same way, while you may design at design time the actual relationship of all the events that are going to flow through your system to make work happen, in this particular case, the customer journey of making a booking, there's nobody actually controlling that process in this model. And what we do is we simply look at the good old pipeline approach, right? So a pipeline essentially says I have a source and a sink. There's someone who originates the actual workflow, someone basically is the final step in the workflow, and in between I may have an arbitrary number of steps that I pass through. Okay. And this is a very common approach in messaging, is to use pipelines to solve problems. So my direct booking comes into my direct booking service, and it doesn't have the credit card details that I need. But what actually listens to direct booking made is going to be the account system. And the account system, when it picks it up, is going to say, I know that when I receive a direct booking is made, what I do is I enrich the content of that message with credit card details. We tend to refer to this pattern as a content enricher. It has the credit card details, and it may raise a message saying, for example, new booking with credit card details. And that's what credit card payments then listens to, is that other message, which effectively means it now has basically the booking details with the credit card information it needs to take the booking from the customer. And that pipeline approach of enriching the data such that the person that needs to action it is actually quite a common way of solving problems. Okay, so what happens if there's an error in this model? What happens if credit card payments basically can't be enacted? Because errors in pipelines are an additional problem with pipeline architectures. What happens if I get an error down towards the end? Well, the simple answer with choreography is that credit card payments microservice raises an event saying there was basically insufficient funds or whatever error, or credit card has expired, and it raises a credit card payment error. And new bookings essentially can listen to that error and say, hey, there was an error raised against the credit card payment for this booking. I'm going to suspend the booking. And then it may in return now say, hey, when I suspend a booking, what I do is issue a message so that effectively we can begin the process of contacting the customer to ask them to present new card details. And so I'm going to raise a message that goes to accounts so that accounts can enrich that message with the customer contact information. And that can then appear effectively via another service in somebody's inbox to actually action calling the customer and trying to basically get a new credit card details, or even sending an email to the customer to ask them basically to represent their credit card details in a certain time frame. And that's choreography. And the real advantage of choreography is that we retain this event-based model. And the event-based model says, I, as the publisher, have no awareness of my subscribers. I simply know that effectively my job is to publish these events and that other people take action. And that means we have a lot of decoupling between our systems. Right? The disadvantage is that it's very hard for anyone to understand what state is this booking in. That's a traditional problem with the pipeline architecture. You read about classic pipeline architecture patterns. One of the things that comes out, people say it's pretty unclear from the point of the feedback to the user at what point there in the pipeline their particular request is. Now, an answer in pipeline architecture is something called a wiretap. So a wiretap says, I sit and I listen to all the messages flowing down the wire, and then effectively I can keep updating what state the order is in. Where has it reached? Oh, it's currently getting the account details. Oh, it's reached credit card payments and it's trying to take credit card payment. Oh, it's raised an error and basically the booking has been suspended. And generally that piece of data, you just wrap an API over it effectively, and somebody then basically in your help desk can always then dial in with the booking ID and figure out where the given basic transaction is, right? And for example, that Just Eat, that's a very common way of us figuring out where your order is. But if you're kind of unhappy with that model of just having kind of some monitoring going on, you may want to move towards orchestration. Orchestration, another couple of benefits to talk about in a second. So orchestration is the model that there is a conductor. There is somebody controlling the whole orchestra as they begin to actually move through this journey of conducting work. And so with orchestration, I may use this idea of a process manager. Now, also folks call it Saga. We don't really get into whether Saga is a good name or not. Saga, and particularly in the .NET community, is the word everyone tends to use for this. But essentially, I'm running effectively something that has multiple steps that I need to process. Generally speaking, for me, the process manager essentially always lives outside the microservices, right? Some people put it in the initial microservice. I think the problem with that is you move the workflow into one microservice, is a bit of a lie. You have effectively externalized some of the workflow. And so what happens with this model is the process manager basically gets told, we're going to make a booking. The process manager effectively stores something in its database which says, I am now running this particular booking workflow. And it has an ID for that. And then it sends a message, right? Generally, basically, you can use messaging to do this. You don't have to basically use HTTP. You can use a request response pattern in messaging. And what happens is I send a message to bookings and I say effectively, hey, here's a new booking request. Bookings goes away and satisfies that, makes the booking. And then effectively what it does is it responds to me with information about that booking. What tends to happen is I tend to give you a private channel to reply on. I'm not interested in everybody listening to booking responses. I have some private channel. Quite often I advertise the address of that with whatever format I'm using, AMQP or an SNS endpoint topic, and say, okay, you should reply here. And then effectively you reply back with another message, and I pick that up. And when I pick it up, I say, okay, what was the particular booking workflow that I'm interested in? I weight that up and look at it and say, okay, I've now got the direct booking. The next step in my workflow is to gather the credit card information. So again, I send another message towards basically the account system, and I say, please, can you give me back the credit card details? And then again, effectively, it then raises a message saying, here are the credit card details for this particular booking workflow. I listen to that. I wake up my particular workflow and I add the credit card details to it. And you can see in the top left-hand corner, we refer to this as command-oriented rather than the previous one, which we refer to as event-oriented. That's because our process manager tends to know that this particular system it's talking to is going to handle those messages and give it a response back. We have much tighter coupling here between the process manager and the individual steps that it's dealing with. And then finally, what may happen is basically I say, okay, let's basically send my enriched booking message, which has the credit card details, etc., effectively to this, takes a payment, right? And I can take the payment, that comes back, another workflow effectively says, great, I am now done. I have reserved the room for the customer. And in return, probably what it does is essentially it then says, I'm going to now update basically direct bookings and tell it basically, which we're not showing here, tell it basically to mark the booking basically as complete. What that gives us essentially is a view of the process the whole time. We can always ask the process manager what state it's in. Now, we haven't really got any significant advantages at this point over using choreography, and we've actually got more coupling. So why might I want to do that? So generally, it's to do with how we manage errors. In the choreography model, what happens, for example, if I can't take a payment, is that my credit card payment service raises an event saying couldn't take the payment. But there's not necessarily a guarantee that we're going to actually basically terminate that booking, because I'd have to rely on the message having guaranteed delivery to basically the booking service to pick it up and get hold of that information. I'm just raising an event. I don't even know if there's a booking service that's going to listen to it. So in circumstances where I want to guarantee that my booking is actually going to get reversed so other customers can now book that hotel room instead, the advantage of a process manager is that essentially it gets the response back saying I failed to take basically the credit card correctly, and it will keep retrying to tell the direct booking service that, hey, you need to cancel that booking. Right, and then it in return can then basically send a message out which basically says, hey customer, please represent your new credit card details. So in other words, if I require quite strong guarantees around basically the compensation flow, I may end up with basically using a process manager. And really it's a business decision as to kind of what happens. Interestingly enough, I was explaining to some people the other day that Just Eat, for example, what happens is because we don't control all of the delivery, some of it happens by individual restaurants, some of it happens by third-party couriers, only a small proportion happens by our own couriers. And even then, even when it's our own couriers, we can't guarantee they're always going to press the button. So we quite often don't know whether food's been delivered to your house, right? And so what we actually do is we assume food has been delivered if we don't hear after a certain point that food's been successfully delivered to your house. Why would we do that? Well, because you'll tend to phone us up and complain if you haven't got your food. So we don't really need this kind of guarantee of some kind of process manager because we assume by the business process that a human being will actually deal with that for us. The other kind of model that essentially process managers are particularly useful for, and it comes into play quite a lot in the hotel industry, is the reservation pattern. So the idea with the reservation pattern says there's a lot of demand for rooms, and I want to make sure that I don't have some room in some kind of suspended, we didn't take a payment state for long. I want to make sure that the transaction gets completed, or else we make the room available to somebody else. And so typically what might happen is the user's making the booking, and when the booking starts, we start a kind of a timer. So generally there's some scheduler that's running the process manager which says this booking ought to have completed in this time frame. And as we go through the rest of the process, if for some reason we get a failure to actually basically reach the end, perhaps, for example, we didn't get all the details we needed from the customer to complete the credit card payment portion of the work, then we can time out that given transaction effectively and then reverse the booking. And that then frees that booking up for somebody else. So if you try and buy tickets for basically, the movies or effectively for a concert, you'll quite often encounter the reservation booking and you'll see a timer on your screen saying, hey, you have 10 minutes to complete this. And again, process managers can help you run that. One thing to be wary of with this model is that we are potentially, as soon as we use orchestration, back in the model of an entity service. You can obviously see how easy it would be for all of the business logic to end up now clustered in the process manager and for us just to have entity services again, which basically we're done. Okay. And this is the problem in what we would call SOA2, which is often described as the enterprise service bus. We had these tools like BizTalk, for example, that sat in the middle, that had these workflow tools that could manage and build workflows and run rules and individual logic. And what happened was they became the center of our universe. The universe was basically hidden away inside some vendor-based product, and the individual services we were building were very dumb. And this is where this expression smart endpoints and dumb pipes you'll see comes from, which is referred to in Mine Fowler and James Lewis's article ThoughtWorks over of microservices. From this idea, effectively, that the business logic is creeping away into the enterprise service bus. And really, it's an expression of this same idea. We don't want CRUD-based entity services. We want services that are based around processes. We want that flow through. You'll tend to find if you stick to choreography initially, you're more likely to end up in the pit of success on the bottom half. And if you move to orchestration, just be wary that it can lead you into the dark side, and you end up on the path towards an enterprise service bus model. Okay, so caching reference data. So let this one to kind of last because we've explored this concept already, and it's also much more, a lot of the gotchas in this and the detail is explored in my talk on event-driven collaboration. But we could simply effectively build a cache of data via event carrier state transfer, which contains the necessary credit card information from the user's account so the credit card payment can access it at runtime. And the accounts information then essentially is the accounts basically say credit card details have changed, customers changed their address, customers changed their surname because they got married or whatever, and that's very traditional. Then essentially when the credit card payment comes in, we're able to effectively read from the accounts database to get that credit card information that we need and take the payment. Right? And that's a very simple model again with event carrier state transfer. And typically what we have what you call shared collection data. So that's data where effectively large parts of our system tend to access it. Account data, say for example, Just Eat's restaurant information. It's very common to replicate that so that essentially you can just grab it if you need it in order to complete the work in response to you receiving basically an event. All right. There we go. And in turn, you may raise your own message and someone may listen to that downstream. Right. Oops. On. Click. The next page. All right. So yeah. So as I say, basically, if you want to see there's some more details to understand around event carrier state transfer to do with basically things like producer consumer correctness, where you get into outbox pattern and log tailing, etc. Please do go and see my event-driven collaboration talk, which you should be able to find on NDC's list of videos. And I can always dig it out and share a link in the Slack channel after this. And with that, we are done. I've got a couple of minutes for questions, and I will hang around in the Slack room afterwards when I disassemble my studio here enough to actually better sit in front of a computer rather than have to stand for the whole time. But if there are any questions, I need to try and find the chat. I have so many windows open. Let me kill the presentation, and then I can probably find the chat window if I'm lucky. I'm going to be stumped by able to find chat here.
So the question is, I'm reading, is how to make sure the process manager does not turn into a monolith.
So how do you make sure a process manager doesn't turn into basically, yeah, a horror show basically, and it all becomes a whole distributed monolith? Well, not if that becomes centralized logic in your process manager. I think the thing to do usually is process managers work particularly well inside a given microservice boundary. And the context we're talking about there is it's not uncommon necessarily to, within inside a microservice boundary, say have a container that basically has your API on it, a container that has some worker processes inside it that basically you're offloading work to. And if it's basically within the domain of a single process itself, they work pretty well. As soon as you start to cross multiple microservices with them, you need to start being cautious. And generally, it's kind of okay if it's a fairly straightforward, really what I'm just trying to do is run a timer on a reservation, or really I'm just trying to make sure that I'm ensuring that basically the reversal of the compensation for a failure route, it will be enacted and effectively I'll get retries. If you start to do things like write conditional logic in there, or you start to have too much knowledge around a complex set of interactions and multiple microservices, I would start to be cautious, particularly if you're doing things like making calls to external systems from within your process manager rather than letting your microservice do that, etc. I would start to be pretty cautious. My usual model is start with choreography and only move to a orchestration if there's a problem with choreography's compensation or needing reservation pattern. I can't solve successfully with choreography. I would always make that my default, use events, and then I use commands if effectively I really can't solve the problem that way. And that's not a great answer, but it's kind of like, don't go there unless you know that you're going to pay a price in some behavioral coupling in your system, which will create more rigidity for you. Anything else? Can't quite figure out how to see whatever I've got on my screen is not showing the chat window.
I can read the question for you, Ian, if you want.
Yeah, cool.
So from Bernardo, in your opinion, what is the best technology to build a gateway?
Best technology to
build the gateway.
Build a gateway. That's a really good question. It all depends on your kind of platform. So there are different types of gateway out there, right? So Just Eat effectively has got Kong, which works for some things. It's kind of Nginx on steroids. But if you really want to run actual code in there, you end up in Lua, and it's not particularly fantastic. in Java land, you can use things like hystrix, etc., effectively in that layer, and that's a pretty good solution. In .NET land, you can get a long way with using something like Poly inside basically an API layer, effectively, to do a lot of that work for you. You're effectively adding a proxy or do retry circuit breakers, failovers, that kind of thing, etc. You may need state machines in there effectively. If you're unlucky, you can just get a simple technology to do that. You can, if you want to do lots of composition of APIs, there are things like Apollo using GraphQL, which can basically let you combine various REST APIs together to do work that way. We've not really used Apollo in anger, but it looks very interesting. And GraphQL looks very interesting, a choice for doing genuine composition across multiple microservice APIs in an interesting way with technologies like Apollo behind it to back making those calls to the multiple microservice endpoints. But in terms of a proxy, you build an API and use it for proxy underlying internal APIs, honestly, you can just use anything that basically in your platform supports building an HTTP-based API, and it has logic to support packages that support things like retry, circuit breaker, fallback to a cache, etc. All right, suspect we are close to time. I could probably do questions in Slack at that point. I haven't done. I've got a clock on somewhere. All this technology, and none of them gives me a clock. I got about 4 screens, and I can't see a clock or the chat window in any of them. So that's basically a bit of a fail somewhere. All right. I'll tell you what, guys. I will see you in Slack because I expect we're probably towards the end. I will give me a couple of minutes to get into Slack, and I will get in there and start answering any questions you've got in there. And I'll see you then. Thanks very much for coming.